In one of the first sections, we've learned that the type inference is a crucial feature of Reason, since it will automatically determine the types of your values. This reconciles the flexibility of untyped languages with the safety of typed languages. However, we can also write types manually using type annotations. Type annotation is the way to introduce types in your code by binding a user-defined identifier to a type. It is useful to write type declarations explicitly, as you can give types to your identifiers and functions. Types are not only useful to document programs for other programmers using type annotations, but also to inform the compiler about the shape of values so that it can statically check that they are properly used. In this section, we will learn how to define type annotations in Reason. Let's get started with an example. We get back information that the type of our value is integer. So Reason just inferred the type for us since we didn't write any explicit type annotation. We can also bind our value to an identifier using the let keyword. Again, this let binding doesn't contain any written type. Reason figured the type out for us for free. However, we can also tell the compiler what type we want for our value by writing this type explicitly. This is how we annotate types in Reason. We write a let binding followed by a colon, and then we write our type annotation. In our example, we stated that the identifier num is of a type int and of value 51. If you do write a type annotation for value, the compiler will make sure to check that it's consistent with how that value is used in your program. What will happen if we insert an incorrect type annotation for our identifier? Let's take a look. We got a type error since we set the type of our identifier to a string, but we provided it with the value of an integer. Let's talk about types as documentation. A primary usage of types is to document your code in order to explain to other programmers how you use primitive types to encode some specific form of information. Let's take a look at an example. In this example, we want to implement the toLowerCase function that converts every string to lowercase. We may want to document that by saying that it takes an argument, which is a string. Then, inside the body, we convert that string using a built-in function that transforms our string to lowercase. This means that the result of this expression is always a lowercase string. However, we can document this code even more. This is called type declaration, and it means you can refer to a type by a different name. The type declaration as well as its type are equal. In this case, our lowercase type declaration is equal to a string. We can now use it in our example. We've just assigned our lowercase type as the return type of our toLowerCase function, just by using a colon followed by the name of the return type just before the equal sign, as you can see here. So, we've documented that the toLowerCase function will always return a type named lowercase, which implies by its name that it should return a lowercase string. Now, we need to keep in mind that our type, lowercase, is only documentation. This means it doesn't provide more static guarantees than a string type. Now, let's verify that. This code was accepted by the type checker, even though we passed an uppercase string to the lowercase type. So just think about these simple type declarations as more of documentation for you and your fellow developers. Let's now take a closer look at type declaration syntax. To declare a type, first we have to use the keyword type, followed by a type identifier that we've chosen, and then after the equal sign, we just have to write the type definition. A type identifier must start with a lowercase letter. You can think of type identifier as a synonym or abbreviation for the type definition. For now, type definition can be integer, boolean, string, character, or float. There are more types in Reason, and we will talk about them in the upcoming sections. We need to keep in mind that only one type identifier can be introduced in a type abbreviation. Let's take a look. If we try to create more type identifiers at once, we will get a syntax error. Now, let's take a closer look at the type annotation syntax. After you've introduced a new type identifier, you can use it to constrain an expression or a definition to be of some type. This is called a type annotation. Type annotations are static, which means they have no impact on the program execution. Let's take a look at 4 typical scenarios of type annotations. Firstly, we can annotate our identifier with a type. Let's take a look. We set the type of our cat identifier to be a string, and its value is a ragdoll. We can also annotate our identifier using a type declaration. We've defined the animal type declaration, which is a string, and then we've created dog and cat identifiers and set their types to our animal type. This means that the cat identifier is of a type animal, and at the same time it's also of a type string, since the animal type is equal to a string type. This means that a value of a type animal is represented exactly as a value of type string. Secondly, we can annotate our function argument with a type. We created a function getAnimal, which expects an anim argument and returns a concatenated string. As you can see, we annotated our argument anim to be of type string. Thirdly, we can annotate or constrain the return type of our function. We have the same function getAnimal as before. However, in this case, we annotated the return type of our function to be of a type string. Here. This can be read as getAnimal function returns a string, so we haven't annotated its argument as we did in the previous example. Last kind of type annotation is that we can annotate the type of any other expression. Here we created a function getTitle which expects 2 arguments, condition and expression. If condition is true, we will return the original expression argument. Otherwise, we will return its concatenated version. As you can see, we annotated only the case if the condition is true. In such situation, we will return a string. In general, any expression might be annotated. However, with basic Reason code, type annotations are mostly used for documentation purposes. That's why we usually annotate the function parameter and not a sub-expression. So our example will make much more sense if we annotated the argument. As you can see now, we annotated our argument expression, which is a type of string. Let's take a look at what kind of programming errors we can get when we use our own type definitions. What will happen if we use the same type identifier for several definitions? Let's take a look. And we got an error message, which is a little bit cryptic. Compiler is telling us that X has a type of animal, which is a string. However, function func is expecting a value of the second version of the type animal, which is an integer. You can notice that Reason is showing us numbers of both versions of the animal type to distinguish between them, here and here. So you should avoid using the same type identifier for several definitions. We also need to keep in mind the inherent limitations of type synonyms. We've already talked about this earlier, that this type declaration, lowercase, is only documentation. This means it doesn't provide more static guarantees than string type. Let's verify that. This code was accepted by the type checker, even though we passed an uppercase string to the lowercase type. So just think about these simple type declarations as more of documentation for you and your fellow developers. Fortunately, Reason's type system will help us define more precise types, which will enable us to catch these kind of errors statically. We will see this in the upcoming sections.